Okay, so this is the second video for activity 3.1, and what we're going to try to cover here is how we recognize exponential functions versus linear functions in a table. Okay, let's remember how we recognize a linear function in a table. I would like you to look at table number 1, which is my first table right here. And in this table, I have input and output, and I want to check if this table represents a linear function. Well, these outputs seem to be consecutive. Consecutives as 0, 1, 2, 3, 4, 5. Those are consecutive numbers. So if I subtract the outputs corresponding to consecutive numbers, in a way, I'm finding the average rate of change, correct? In other words, the average rate of change here is 2 minus 0, 2 minus 0 divided by 1. The change here in the input is always 1, right? So I don't need to write the 1. The average rate of change here is 2, right? So subtracting consecutive outputs in this particular table gives me the average rate of change, correct? Okay, so let me go between the second and third output, the average rate of change. Again, all I had to do is to subtract 4 minus 2, and 4 minus 2 is against 2. Average rate of change between fourth output and third output is 6 minus 4, and 6 minus 4 is 2. Yes, so this function is linear, and if somebody asks me to find the equation of this function, I would say that f of x or y is equals to m. This is the slope, so it will be 2x plus mx plus b, right? And b is equals to 0, 2x plus 0, which means that the equation for this particular function is y equals f of x equals 2x, or y equals 2x, right? That's the equation of this particular function represented in this table. Okay, again, remember consecutive outputs, consecutive inputs, all I have to do is to calculate the difference of consecutive outputs. Okay, so let me go with table 2. Okay, so the inputs are consecutive. Let me subtract the outputs, okay, and see if I get the same number. So here a minus 4 is 4, right? 4 minus 2 is 2. Okay, so average rate of change is not constant, correct? Okay, now I'm going to do something with table 2, and I want you to see how interesting this is. I'm going to erase this, okay, because I'm no longer interested in subtracting. I'm more interested in dividing, okay? So what I'm going to do is I'm going to divide the outputs corresponding to consecutive inputs. So let me divide a by 4. That, that gives me a 2. Now 4 divided by 2, that gives me a 2. And 2 divided by 1, that gives me a 2. Okay, so what I'm getting here is that if I divide outputs corresponding to consecutive inputs, I get a constant number, and that number is 2. This is the basic principle of an exponential function. This function right here is an exponential function, and the equation of this function is y equals, this number right here is my factor, so it's 2 to the x, okay? My a value is the y-intercept, right? And in this case, the y-intercept is 1. So in this case, the function is y equals 2 to the x. Okay, so what did I find here? This number right here is my b. This number right here is my A. Okay? Alright, let me look on with, now I'm going to look at table number 3. Table 3. Yes, and then let's see what happens in table 3. Is this function linear? Again, I look at the outputs. The inputs rather are consecutive, so the output correspond to consecutive inputs. And my first thing, my first instinct is to subtract and see if this is linear. So 9 minus 6 is 3. 6 minus 3 is 3. 3 minus 0 is 3. Okay, so it's linear, right? Why? Because when I subtract consecutive outputs, the number is constant. This number that is constant is the slope of the line, m equals 3. This function right here is the function y equals mx plus b, but m is 3, so y will be equals 3x plus b, and remember that b is right here, 3x plus 0, so the function is a linear function given by y equals 3x. Okay? Now let's go with table 4. Table 4, and in table 4, again I have consecutive outputs. Yes? And what I'm going to do is I'm going to subtract these consecutive outputs and see what happens. Okay? So let me subtract 1/8 minus 1/4. If you want to subtract 1/8 minus 1/4, you can do it in your calculator. Okay? The answer is negative 1/8. Okay? And if you subtract 1/4 minus 1/2, right? The answer is negative 1/4. Okay? So average rate of change is not constant in table 4. So the function in table 4 is not linear. So what I'm going to do is I'm going to erase these, and we're going to check if this function is in fact an exponential. I know that this function is not a linear function. I'm going to check if it's an exponential function. Okay, so I'm going to start dividing outputs related to consecutive inputs. So here it goes. This is not really the good thing. So I'm going to divide 1/8 divided by 1/4. And if I divide 1/8 by 1/4, you know what? I'm going to erase these, and I'm going to erase this part right here, and I'm going to do this work on the left side. Okay, I'm sorry, my apologies. This thing, okay, very good. So I'm going to work right here because this is going to require a little work. So I'm going to divide. So I'm going to have 1/8 divided by 1/4. If you remember your division of fractions, you have to flip, right? And the number is boom, boom here, you cancel, and you get 1/2. So here, the result is 1/2. Okay, now let me divide 1/4 by 1/2. Again, you have to flip the second one, and you cancel. The answer is 1/2. So when you divide here, you get 1/2. Now let me divide the last one. 1/2 divided by 1 is 1/2. Okay? So this function in table 4 is an exponential function, and b is equals to 1/2. Correct? Remember that equation is y equals ab to the x, right? So the equation would be, let me write it right here, 1/2 to the x, right? And remember the value of a is going to be given by your y-intercept. So it's 1 times 1/2 to the x. That's the equation of the function given in table 4. Okay? So let me remember now, or let me remind you what is an exponential function. This is an exponential function. This number right here represents a factor. This number right here represents the y-intercept. Okay? This factor is the number that we obtain by division of outputs corresponding to consecutive inputs. Okay, let's see if we understand this concept. And to practice this concept, I would like you to open your book in page 204. Okay, so let's go to the book to page 204. And what I would like to do is I would like to look at problem number 16. Okay, number 16. In number 16, you have two tables. I'm going to go with table A. In table A, you have X and Y, -2, -1, 0, 1, 2, 3, and 4. And the numbers are these numbers right here. And the book is asking me, if you read the textbook, they're asking me to determine if the data set is linear or exponential. Okay? So if it's linear, I'm going to determine the slope. If it's exponential, I'm going to determine the factor. And then I'm going to have to say if the factor is a growth factor or a decay factor. Okay? Remember that these are the outputs, and these are the inputs, and these inputs are consecutive. Okay, all I have to do is subtract the outputs to check if it's linear. Okay, so you're going to subtract outputs because we have consecutive inputs. Okay, so here we go, 16 minus 2. I'm going to write here the answer is 4. 12 minus 8 is 4. 4, 4, 4, and 4. Okay, so what I have found, that I'm going to write this down, that the difference of outputs corresponding to consecutive inputs is constant. Okay, so that number that you have right here, this number is what I'm going to call the slope of this linear function. So now I have that m is equals to 4. Okay, so now I have the value of m. So I have found that the table represents a linear function. The table represents a linear function, and I know the value of m. M is that constant rate of change that I found in the table. Can I find the equation of the linear function? Sure I can. The formula is f of x, y equals mx plus b, right? M is 4, so y is equals 4x. And if you look here, you can identify the value of the y-intercept. And what is the y-intercept? The y-intercept is 0. Okay, so what is the formula that we have for f of x? F of x is equals to 4x. Okay, that's problem number 16 in page 204. The last problem we're going to do, the very last problem we're going to do, is problem B in page 204. Okay, so page 204, we're going to do problem number 16b. And again, I have a table. I have data points. Data points. Let me write the y values. I have the same question to answer, right? The question is, does that table represent a linear function or an exponential function? Okay. Again, I'm going to check the easiest thing, which is I'm going to check if the difference of output corresponding to consecutive input is constant. In other words, I'm going to subtract these numbers, okay, and see if I get the constant number. Let me start with the easy ones. This seems to be easy. 16 minus 4, right, is 12. 4 minus 1 is 3. So right away I see that this function is not a linear function because right here I don't have a constant rate of change. Okay, so why don't we check if this function represents an exponential function. To check if it represents an exponential function, instead of subtracting, I'm going to divide. Okay, so in other words, I'm going to divide to, let me just go with red. So I'm going to divide 256 by 64. I'm going to divide 64 by 16. I'm going to divide 16 by 4. Okay, I'm going to divide 4 by 1, 4 by 116. Okay, well, if we divide 215 by 64, we know that we get 4, right? The answer here is 4. Okay, here the answer is 4. Here the answer is 4. Here the answer is 4. And here if I have to divide, I have to flip, and then I cancel. The answer is 4. Okay, so this number right here, let me write what we found, okay? So I found that the quotient of outputs corresponding to consecutive inputs is constant. Okay, so it's not that the difference, the quotient, which means the division. Okay, so this number right here, that b, that number, that 4, is my b, is my factor. Okay, because in this case b is greater than 1, this is called a growth factor. Okay, it's a growth factor. What is the equation that I have here? The equation would be a times b to the x. A is my y-intercept, b is my factor, okay? And that means that y is equals to, my y-intercept is 1, right? Looking here is 1 times 4 to the x. So my function is y is equals 4 to the x. Okay, I did a little bit more of what they were asking me in the book, but I think this is a good example and a good exercise for you that will help you with the homework. Okay, I think you will be ready to finish activity 3.1 and to do the lab corresponding to 3.1.